delegates and participants from across the globe. A very warm welcome to you all.
Today's keynote address is a significant highlight of this conference as it set the tone, direction, and vision for the discussions that will follow. It's our privilege to introduce our esteemed keynote speaker for this session.
Dr. Soni Jonti is a distinguished sports psychologist currently associated with the Indian archery team, where he plays a vital role in enhancing athletes' mental strength, focus, and performance at the highest competitive levels. He is a retired professor and former head of the Department of Bachelor of Physical Education, Christ College.
With decades of rich academic, administrative, and field experience in the domain of physical education and sports psychology. Dr. Soni Jonti is widely respected for successfully bridging a gap between theory and practice, applying psychological principles directly to elevate sports performance, particularly in precision sports like archery.
With great honor, I invite Dr. Soni Jonti. Along with him, I invite Deepak sir to hand over the ID card of the International Conference to begin the session. So, I invite Deepak sir to hand over the ID card of this International Conference.
Hello.
A warm good morning to you all. I would, on the outset, thank my professional colleagues here at Christ College for organizing such a wonderful conference and especially for inviting me as one of the keynote speakers. My topic today is brain and motor performance. We all move around, all living beings. Movement is the most important feature of a living organism. If you have life, you move, right? And you move and you observe movement as a form of behavior. But there is a lot of functional process going on before a movement is produced. And it is essential for you to understand what is the functional process behind that movement, to understand motor learning and performance, and at the end, sports performance. So there is a bit of bridging the gap between theory and practice here. There is absolutely no doubt about it. Let's go down to the next one. Three fundamental layers of the brain. I am taking a leaf out of Sapolsky from his book, very famous book, Behave. It's a very famous book and one should read it actually to understand what is the functions behind some of the psychological features of humans. And he categorically states that there are three fundamental layers of the brain. Layer 1, found in all species. And layer 2 is something that is found in mammals. Whereas layer 3, which is the neocortex, found in primates, devote more of their brain to this layer. Primates have a lot of neocortex. The third layer is very, very large in primates. That's what is permitting them to think a lot, to do a lot of cognitive functions. If you look at those layers and its importance, it's written the action part of the brain involved in automatic regulatory functions, which is mostly connected with the survival aspect of living beings. and it is there in every species. The second layer is emotional layer. For example, emotions like limbic system and all that, where the human emotional centers, brain's emotional center is situated, like amygdala or sinus and all that, right? And layer 3, the most important one is neocortex, which carries on the cognitive functions, memory, sensory processing, abstractions, and philosophy, everything of that sort. And neocortex is something that makes man the man that man is. Right. Let us go to the next one. General regions of the brain. There is a frontal cortex here. This is the frontal cortex. Then there is a parietal region here. And there is a temporal region on both sides. We call it temporal region. Then at the back, we have occipital region. Occipital region is the region where we see, actually. We all believe that we see through our eyes. It's only lens here. It's only lens here. But we see images at the back of the brain, at the occipital region. Go to the next one. Okay, brain major structure and functions. This actually, I'm giving these structures in relation to motor performance, not the other things, because there are Broca's areas and other areas of the brain. Broca's area is related with language and all that. There are several other regions as well as in the brain. I'm not concerned about it. I'm just concerned about it, major structures and functions in relation to motor production. Motor cortex, the most important. At the parietal region, we have the motor cortex. We have primary motor area, premotor area, and supplementary motor area. That is what is motor cortex is all about. That is where the motor actions are planned. That is where the motor actions are planned and the wiring happens to start with. The wiring of the neurons happen to start with in the motor cortex. The second one is prefrontal cortex and parietal cortex. Prefrontal cortex is this one, actually. Okay. The major function of prefrontal cortex is we have the working memory resting there. We also have, we make choices. When we make choices of our action, and that decision is made at the prefrontal cortex. Whereas parietal region of the brain is the region where the imitation takes place. Imitation is one of the most important aspects of our learning, actually. We learn most of the things through imitation. And our brain is wired in such a way that we are made for imitation, actually. Previously, we used to think that imitation is a low quality kind of thing, but it is not. Today, we know that thanks to Albert S. Bandura, actually, he is the one who brought out the social learning theory of imitation, actually. How we learn different things through imitation. For example, children learn how to write, how to walk, how to sit, how to eat, how to dress, all through mostly imitation. And it happens because there is a particular specialized branch of neurons in parietal region functioning on that. One of my studies in my PhD was exactly about recognizing the areas in relation to imitation. And we found that in parietal region, there are neurons who are very special in nature. In brain, usually there are two types of neurons. In brain, there are two types of neurons. One is motor neuron, the other one is sensory neuron. But at some stage of evolution, we understand that these neurons, some of these neurons at certain areas of the brain turned into dual role. They can sense from the environment, also they can produce motor movements. And we call those neurons mirror neurons. They mirror others' action and they also imitate others' action. Mirror neurons. Parietal lobe is the area of the brain where we have mirror neurons helping in imitating others' actions. That is why I said at the start that human brain is wired to actually produce imitative actions. Right. Now, limbic region. Limbic system is the system, I already spoke about it, it's the emotional center of the brain. If there is an emotional change in us, limbic region is in charge of the brain, actually. Right. Now let's look at the other one, the more important for us, cerebellum and basal ganglia. That forms the first layer of the brain, actually. The most fundamental layers of the brain. We know that limbic system belongs to the second layer of the brain. Whereas prefrontal cortex, parietal cortex, motor cortex, third layer of the brain. The latest development in human brain or primates brain is the third layer, that is motor cortex and prefrontal cortex. The first layer, we said that it is the most fundamental layer, that is cerebellum and basal ganglia. We usually call these structures subcortical structures. Below the cortex, subcortical structures. And we'll go deep into that later. Let's go to the next slide, please. So that is a diagram of premotor cortex, supplementary motor area, then premotor cortex, primary somatosensory cortex, posterior parietal cortex. Major areas where movements are initially produced, or rather neurons are initially wired in relation to the movement that you plan to produce. Okay, let's go to the next one. Functions of motor cortex, responsible for controlling voluntary movement. Responsible for controlling voluntary movement, its neural pathways are refined and strengthened through repetitive practice. When you practice repetitively, those pathways, neural connections are strengthened. The basic principle in psychology, the most basic principle in psychology, there are two things in psychology basically. Only two things. Stimulus and response. That is what psychology is. Stimulus and response. We all do that. All living organisms do that. We take stimuli or a stimulus from the environment and we respond to it. Stimulus is singular and stimuli is plural. Right. So when we see a stimulus, for example, you're driving on the road. Suddenly you see the red light. You respond by braking, stopping the vehicle. A simple example for stimulus response. But what happens here when you do that repeatedly? The wiring happens here in the brain. The wiring happens here in the brain. That is why we say that when we usually teach a kid to hit a ball, in cricket what usually happens, we throw a small boy a ball and the boy is likely to miss it all the time. And parents, in India it's quite widely seen. Parents have a tendency to throw the ball to the small children to see them hitting, and they start predicting that he is going to be the next Sachin Tendulkar or something of that sort. But every time the boy or the girl misses the ball, what is actually happening? In brain, the stimulus response bond for the missing is being strengthened. That's why we always tell them, keep the ball down, make them hit the ball. Don't throw it to them, keep the ball on a tee or on the floor, make them hit it. So more important that they contact the ball, so that there is a stimulus response process happening in the brain which will strengthen the stimulus response bond between hitting, one of the fundamental or one of the most basic motor movements, hitting. Right. Now when we come back to this thing here, this is the initial thing actually in the motor cortex, initial wiring. When you plan, when you start doing, initial wiring happens in the motor cortex. But the actual beauty is that the brain is such a device, after some time, motor cortex is not worried about whether you are doing that movement or not. And certain other centers are worried about producing that movement. So when you teach someone initially a skill, it is the motor cortex that is getting involved. The wiring happens in the motor cortex. And you train, practice. And at one stage what happens, the entire process of doing that particular skill shifts from motor cortex to other areas of the brain. Right? Okay, let's go to the next one. Functions of cerebellum, very important. Coordinates, regulates muscular activity, balance and agility, becoming more efficient in skilled athletes. If you need good athletes actually, if you need good athletes, you need real good coordination, we know that. But I would say that athlete needs real good coordination among different centers of the brain. We see neuromuscular coordination here. If you want to make that possible, there should be good coordination among different centers of the brain here. That's very important. So cerebellum, what cerebellum does is that it produces automated movements. Cerebellum and basal ganglia, we call it. These are the two centers, subcortical centers of the brain that produces automated movements. If a footballer, when he moves around to the striker's position, see the ball coming, automatically he jumps and heads without thinking. Is he thinking? He is not thinking. He is doing an automated movement. It is there in his cerebellum, and it is produced from the cerebellum, not from the motor cortex, because that is an automated movement for him. Automated movement for him. So I made this product. The most important thing is that, the most beautiful thing is that I was aware of this thing a bit early, probably in 2006 and all that, and I presented a paper how imagery can be suitably used for the cerebellum. And I got some award for that here in, I think, Mangalore. We presented a paper. But now I find solid research evidence for my guess, actually. That was a hypothesis, that was a guess from my part, actually. It is a hypothetical paper, but now we have solid evidence. Okay. So coordinates, regulates muscular activity, balance and agility, becoming more efficient in skilled athletes. Next one. Basal ganglia, another one. Very important for sportsmen, right? Plays crucial role in regulation of voluntary movements and chunking movement sequences into a single seamless unit, hallmark of automaticity. Seamless movement. There is no need of thinking about the movement. It keeps coming. It keeps coming. That is the task of the coach. The coach, when he trains an athlete, the coach is trying to get the athlete's brain conditioned, actually, to produce automated movements. When somebody is playing, very less time for him to think. And I firmly believe that. I keep telling some of the athletes when they come for the, see, it is this thing that if you keep thinking on the court, you are not going to perform. Because you are activating your higher centers of the brain, the cognitive centers of the brain, which is not what required when you are on the field. What we require is activation of the motor areas, execution of the motor actions. So thinking a lot on the ground is actually counterproductive. You know what I mean? It's actually counterproductive. That is what happens when someone takes timeout in volleyball. The actual purpose of timeout is only one. Because the other team has continuously scored 3 points, we have to break the rhythm of the team. Take a timeout. If the coach is not smart enough, if the coach doesn't have enough information on this, he keeps telling the stories to the players, and all those stories goes to the brain. If they start thinking about it, the cognitive regions of the brain will be activated. There will be a break in rhythm, actually. That is the only purpose of timeout. If the coach is smart enough, he wouldn't tell a lot of things to the players. He would tell that keep playing like the way you play. That is the only thing that you can say. Right. So this is a very important thing. So our purpose here is to get cerebellum and basal ganglia adapted to the demands of an athlete. Demands of an athlete. We need programs that are suitable for getting the athlete condition. Now there are sports like, for example, I was working with archery. So there are sports like archery and shooting. They are very different, very difficult combinations, because they take an aim. When they take an aim, naturally there is a lot of thinking going on here. The cognitive process is active. So how are we going to manage this? It's very important, because there is a decision time, then there is an execution time. That makes that sport very peculiar. Target sports are very peculiar. So that needs some management. We'll come to that later. All right, so basal ganglia, go to the next one. Prefrontal cortex, involved in decision making, attention, I told you that. Decision making, attention, working memory, a skill becomes automatized, activity in PFC often decreases. Prefrontal activity decreases when the skill is automatized. Motor cortex activity is decreased when the skill is automatized. Activation increases in basal ganglia and cerebellum when the skill is automatized. Right. Neural efficiency hypothesis is reducing overthinking and allowing for smoother performance. One of the aspects that prevents motor learning is hypothesis testing behavior. I don't know whether you know about it. One of the aspects in motor learning actually. When we perform a skill, for example, we are performing kicking. Okay. Now usually what happens when somebody performs? Usually what happens after kicking? The performer starts thinking whether I did it right or wrong. He'll start analyzing his movement and compare it with somebody who does it better than, in a better way. So this is we call hypothesis testing behavior. And what happens here, this hypothesis testing behavior can actually hinder learning progress. So one has to be really very careful. It is true that the performer will have to think a bit, but how much? There is a point of threshold which you need to really fix. So that is one aspect which is always related with overthinking, hypothesis testing behavior. Next one, the limbic system, the system that controls the emotions of the brain. We have amygdala body there. Amygdala is a Latin word for what we call this ബദാമിന് പറയുന്ന പേരെന്താ? Almond. Almond. Amygdala in Latin means almond actually, because its shape is almond. Its shape. So these are the areas that control the emotions of the brain, like pineal gland, fornix, corpus callosum, hippocampus. Then there is also hypothalamus or hypothalamus, whatever way you pronounce it. So this is the area, the second layer of the brain. In between cortex and subcortex, there is an area that is called limbic system, which controls our emotions. Okay? When you perform, when you play, it's a very important region actually, because the way you move, the way you use your strength, the way you speed up yourself, all depends upon how well your limbic system works, right? That is one of the reasons why I said that if you need a well-coordinated performance from an athlete, you need his centers, different centers of the brain coordinate really well. Go to the next one. What happens when motor learning takes place? This is very important, look at it. Changes in the neural network takes place through plasticity. How does neural thing takes place? There is a quality called plasticity, where the brain neurons, brain cells have the ability to network. So it can change its structure within that. There is a very popular research where somebody, I forgot his name. I have this thing with names that I forget this. I keep forgetting the names. I don't know whether I'll get some memory loss later, but I usually forget the names, you know. Right, but anyway, I forgot his name, but that researcher, what he did was, he and his team took hold of a monkey which is kept for research purpose and did its brain mapping and marked the area where the thumb is involved in the brain. Now what they did is a bit cruel actually. They cut the thumb of the monkey and left it to live freely. After 3-4 months, they took the monkey back, again had a brain reading, map reading, and they found that the brain areas previously involved in using the thumb is now being occupied by the adjacent palm areas. That means there is a structural change in the brain. And it keeps happening. It's not that it happens only in the childhood, no. It is going on throughout your life. Throughout your life. Neuronal changes, structural changes happen all the time. Okay, the moment Rajesh goes getting ready for singing a song, he thinks about it, he imagines about it, there will be some change accordingly. Right. Okay, so change in the neural network takes place through plasticity, facilitating creation of new network according to learning. So that happens here, the network formation, right? This mainly happens in motor cortex while learning takes place. Mainly it happens in the motor cortex. The blueprint of the movement is created in the motor cortex. Gradually, this synaptic connection strengthened and thus neurons involved are more likely to fire together when motor execution happens. Neurons, they are what? Together, they fire together. You know, nearby neurons, they fire together, right? So that structure, when that network is formed, usually when that motor action is produced, those neurons fire together, right? The representation area of a particular muscle involved in learning can increase as the learning progresses. If you are using a particular, for example, you do a lot of biceps. So there is a representational area in the brain for the biceps. So when you keep doing exercise for the biceps, the representational area for the biceps in the brain can enlarge. Okay, that shows that more blood supply and nutrients to that particular area of the brain because that muscle is being used continuously by the individual, right? So if you look at somebody playing football, the foot area of the footballers in the brain should naturally be larger than others who do not play football because his foot muscles are continuously used in the activity that he is or she is involved, right? The last one, the representation area of a particular, I already explained it. Next one. Motor learning stages. There is a cognitive stage where you have the ideas are formulated, ideas in relation to one particular, movement. So that is the cognitive stage. And the next stage is associative stage. In associative stage, what happens? The neural changes takes place. Okay. And last, the autonomous stage, what happens? You know, the brain delegates basal ganglia and cerebellum to perform those movements gradually. Now, it's a very beautiful situation. Now what happens? The brain is capable of doing the activity as well as thinking because no more the activity is or the movement is performed by the cortex. So the cortex is free actually. But brain also has a problem. When it is involved in producing movements, high intense movement activity, the whole brain is involved in producing that movement. The whole brain supports basal ganglia and cerebellum to produce that movement accurately. So people talk about, that what is it? Mind. Mindfulness. You know about mindfulness. You all know about mindfulness. But I have a question. When somebody is playing, what kind of mindfulness he'll have? I always tell archers, your mindfulness is just to shoot. There will be several things going on the other side, this side, and there will be some, announcements, some music. If you keep mindful about those things, will you be able to perform properly? No, especially when you are switched on. You are switched on to shoot, and if you take attention of many things around, it's going to affect your performance. But when you are switched off, I always tell them, look at other things. You're switched off now. Relax. Relax. So they probably sing a song in their minds, so they talk to the opponents. You know, I've seen our Indian archers really very good. Really very good. When they are not shooting, they talk film stories to their counterparts actually. They relax. And one particular archer, the very senior archer, Abhishek Verma from Delhi, the compound archer, World Cup gold medalist, is a master of it actually. He is also Asian Games gold medal winner. The moment he is off, he is relaxed. He probably goes to his phone, he is an IRS officer, income tax officer. He look at things at the office, then immediately when it is time, switch off, then switch off the mobile phone, then come back, switch on. Archery switch on, mobile phone switch off. It's a very important quality actually. It's not that you can focus all the time. No, not possible. You need to learn how to switch off yourself. Anyone for that matter. If you're teaching, you teach for 1 hour, you're switch on, you're in the teaching mode. Change the mode. The moment you come out of the class, change the mode. Relax. Relax. Or the brain is not going to sustain. If you're still in the teaching mode, it's really very difficult for the brain. That is the reason why you want to sleep actually. You all sleep. 8 hours of sleep is essential. Essential, they say. But how many of you sleep for 8 hours? I manage 5.5, 6 hours. If it is 6, I'm really very happy. Very happy. But if it is not 6, if it is not 5, if it is 4, it's going to affect your brain's efficiency naturally. Switch off. Switch off is very important. Switch on is important. Switch off is also equally important. Let's go to the next one. What happens during cognitive stage? Activation of motor control, neural tracts, already I spoke about it. Early plasticity, initial subcortical engagement. Even at the planning stage, the brain starts engaging cerebellum and cerebrum, cerebellum and basal ganglia. Even at the starting stage. Slightly, not a lot, but they give some idea to cerebellum and basal ganglia, what kind of movement you are learning. Next one. What happens during associative stage? Functional redistribution, reduced activity in motor cortex and increased activity at subcortical region. So there is a functional redistribution. Then again, strengthening of neural pathways, synaptic refinement through long-term potentiation. You know what is potentiation? Potentiation is something we call strengthening the bond between stimulus and response. Potentiation. So continuous practice, there will be some strengthening of bond there in the brain for those particular neurons involved in that motor movement. Naturally, that will increase more blood supply to those brain areas involved in that thing and all that. Okay, strengthening of neural pathways, synaptic refinement through long-term potentiation, increased shift towards subcortical activity, straighter shift from dorsomedial to dorsolateral. In basal ganglia, there are striates, and what happens when the movement is automatized? There is a shift in the activity from dorsomedial. Dorsomedial means there is a medial position in the striatal area, and from that medial position, it moves to the lateral position, to the side. That is the only meaning. Don't be worried about those terms there, all right? Subcortical activities, striatal shift from dorsomedial to dorsolateral. Shift in processing, stimuli processing, shift from external feedback to, that is very important. See, once your movement is automatized, your attention moves from external factors to internal factors. For example, you automatically perceive the proprioceptive feedback. You learn to land. Now when you land, you feel the force here, you take a feedback from these joints to the brain and make yourself aware that you have landed safely. So the attention moves inward actually, within the body to look at different things, all right? Feedback from the body. Internal proprioceptive feedback. Neural restructuring. New dendritic spines are formed. Spines are formed, neuronal formations are formed, right? Increased myelination, connecting cortex, cerebellum and basal ganglia. Myelination, connecting between different centers of the brain. I know that it's a bit tough for guys at the graduate level, at UG undergraduate level, but then you need to get some idea what is happening in the brain when you learn something. Because it's an international conference, I understand. So the standard has to be a bit, I have to keep the standard a bit above your benchmark. I'm sorry about it, but you have to cope with this now. Right, next one. All right. What happens during autonomous stage? Brain becomes less active during automatic movements. Brain becomes less active actually during automatic movement. The connectivity between different centers involved in producing action increases. The brain becomes less active, but the connectivity increases. The connectivity increases. Different centers of the brain are coordinated, connected, but brain actually becomes less active, especially the cortical areas. Cortical areas. Okay, brain control and activation moves from thinking centers to doing centers. This is what I said in 2006. Now we have solid evidence in 2010. Rusty and Frankland brought in evidence, research evidence, saying that when you are moving, doing something, the brain stops a lot of thinking and moves its function towards doing centers of the brain. It's very logically very straightforward actually, right? Now, consolidation of brain activity to subcortical areas, free cognitive space result in dual task proficiency. Like when the brain functions or activation or network connections are more consolidated in the subcortical areas, the top areas, the cortex, the cognitive areas of the brain are free actually. So that improves the dual proficiency, multitask ability of the brain. You know what I mean? You talk about multitasking. So even once the movements that you are doing, not only sporting movements, other movements also, you are well versed with movements. For example, a homemaker cooks at home, very well versed with cooking skills and all that. Probably he or she can also listen to other things, process it, while the cooking movements are going on. So multitasking ability increases when motor movements are automatized. Right, reduced errors, physical reorganization of motor cortex through rewriting to keep the motor structure in the permanent blueprint of the motor structure is there in the brain. Then Purkinje cell modification happens in cerebellum. Purkinje cells are those very specialized cells in the cerebellum in producing automated movements, and its modification happens when automation happens. They modify, the structure modify. They are like, flat and long neurons. Flat and long neurons, these Purkinje cells are. And they change their formation, their connectivity, they change. Right, next one. Oh, balancing. Balancing what, Cognition and motor execution. This is what happens. In archery, there is only one thing. If you want to be a good archer, you need to identify how much cognitive process I need before shooting. That's very key for producing the best performance. How much I can think, how much time I can spend on decision making and release. And that sets the rhythm of the archer. That sets the rhythm of the archer, the decision time. If you're a good archer, for example, I can give the example of Jyoti Surega, one of the top Indian archers, world champion in 2023 when I was with the team. Then also the other one, Dheeraj Bommadevara. He was in semi-final, Olympic semi-final in Paris. Dheeraj Bommadevara. They exactly take 1.34, 1.42 seconds. Nothing more than that during the decision process. And they release. That shows that they are in great rhythm. The moment they change their timing pattern, we know that he is out of rhythm. We know that. And it has happened as well. So once what happened? We were looking at their timing pattern, and we found that one of the archers was out of the rhythm. And that archer was really good. Very rhythmic archer. One of the top archers in the world. But we found that that particular archer is losing the rhythm. So that was just before we go to one World Cup tournament in China. So I told the technician boy not to reveal this result to the archer because that will automatically affect your performance because that neural residue will remain there. But after the competition, we rejoined for the world championship. Then I told the archer, blatantly I told the archer, your rhythm is totally gone. I told that archer, it's terrible. It's terrible. And the archer was heartbroken. But I also kept in my mind that I have 3 weeks before the world championship. She can start rewiring because she is already an expert in that, and that's enough time. 3 weeks means there won't be any neural residue or negative feeling, neural residue in the archer. And the archer went back, competed in the world championship, and was part of India's first ever world championship gold medal. And after the competition, when we came to the hotel, I met the archer on the corridor. So I congratulated the archer. I said, you are brilliant. Then the archer told me, you said that my shooting was terrible. I remember now. So I said, that's all right, but you have your gold medal. That's good. The archer had a dry, good smile on her face when I said that. So sometimes what happens, we have to force a rewiring of the activity. It is easy for them because they are experts. They know the activity, the blueprint is already there, so that needs some modification in terms of timing and all that. So it's possible. But there is also a risk. If it goes on the other way, if she loses her confidence or the archer loses his confidence, it can go down at any time. But, thanks a lot. But I have to look at the other attributes of the archer when I make a comment on that. When I make such a comment, whether the archer will take it positively or not. That's very important. Okay, let's go to the next one. So balancing between cognition and task. Decision time. Decision time versus execution. I already spoke about it. Any target sports, there is a decision time. You have to balance between decision and execution. If the timing is wrong, your action can also be wrong. Okay, next one. A psychological strategy to enhance motor learning, chunking of actions. Imagery is another visualization, we call it, but imagery includes all kinds of sense modalities. So imagery, video modeling and imitation strategies, attention focus, analyzing errors, feedback strategies. All these are strategies that you can use to psychological strategies to enhance motor learning. And we use all these strategies in different measures when it is required. Next one. Psychological strategies enhance automation of motor skills, attentional and focus strategies, imagery, varied practice strategies, different kinds of practice. Different kinds of, probably you always do shooting, then probably we will ask them to go for some virtual shooting practice and things like that, varied practices. Or we change the timing. If it is usually 120 seconds to take a shot, we give them only 60 seconds. So the process needs to be made faster. So varied, practice strategies, feedback and motivation, task-specific and implicit learning. You know what is implicit learning? Implicit learning. We all speak, almost all, except people from, for you, you speak Sinhalese. All of you speak Sinhalese without grammar mistake. You speak Sinhalese without grammar mistake. Can you tell me the grammar rules of Sinhalese? Vyagaran? Yeah, can you tell me? No. I speak Malayalam, all these people speak Malayalam. If I ask them the grammar rules, they speak Malayalam without grammar mistake. You speak Sinhalese without grammar mistake. But if I ask the grammar rules, you wouldn't be able to tell me. Will you be able to tell me the grammar rules? You speak Malayalam without grammar mistake, do you? So why are you not able to tell me the grammar rules when I ask? But if I ask you grammar rules in English, you'll be able to tell me. If it is I, it has to be am. If it is single, it is is. If it is plural, are, were, or whatever it is. Right? It's possible. We know that. Because we learned English explicitly. Somebody taught us. Whereas we learned our mother tongue implicitly by using it naturally. And we were never bothered about grammar rules. There are motor skills like that. There are motor skills like that. It is so implicitly learned that the learner won't be explained how he does it. For example, if you ask Messi to explain how you shot that free kick right into that corner, you think he'll be able to explain it? No, but he can do it again. He'll tell, I'll show you again. Wait, I'll show you again. He'll do it again. But if you ask, explain it, he may not be able to do it. Because it's learned implicitly. Without, what is an implicit learning? The learning that happens with the conscious involvement of conscious brain. Unconsciously you learn it. You are not aware about learning it. You learn Malayalam without being aware about learning it. By speaking, responding to queries, you learn it. Not being aware about that, you are learning it. And people learn skills like that. So there are strategies for that. If you want, you can talk to me. I'll teach you the strategies for implicit learning. Right? Not now. Okay. Task specific and implicit learning. Next one. Development of kinesthetic. This is very important. What is kinesthetic sense? What is kinesthetic sense? This is for my junior fellows here. What is kinesthetic sense, Saniga? Saniga. No idea. Movement? It's about movements, but it is not that. It's like you are sitting down to eat your dinner, the light goes. You still know the way to the mouth. You still know the way to the mouth. That is the sensing, the feeling of your body part in relation to the space. Feeling. For example, you might have seen in IPL and other international cricket matches and all that, people taking catches on the boundary line, and the moment they feel that they are going out, they throw it, go back, come back and take it. That feeling that my body position and the position in the space here, you know. Some catches they take. For example, we saw Sanju Samson taking a wonderful catch in the last match. Low, down here, single-handed. Kinesthetic sense. If you need brilliant performance, exceptional performance, that athlete need to have good kinesthetic sense. So when we look at the target in archery, 70 meters through the sighter, it's very difficult to see the target, but you still can hit the target because you have very good feeling for the space and body. That's why we need very good archers and shooters who have good kinesthetic sense. Right, go to the next one. Key brain area, cerebellum, parietal cortex and basal ganglia in automation. Go, next one. In kinesthetic sense, those brain areas involved in kinesthetic sense. Changes in the brain, robust sensory mapping, integrating sensory input and motor output, cues from motor commands, predictive models in kinesthetic sense. Predictive model is very important. What's going to happen next? For example, you're taking the catch, you're predicting that the next one is that I'm going over. So here, the predictive model tells me that I am falling over, throw the ball, go out, come back and take it. So that predictive model is very important in kinesthetic sense. Next one. Functional change, confident. When learning becomes automatized, confident moves, muscle memory, enhanced learning and rehabilitation, extreme physical performance, enhanced sense of timing. Timing sense improves. Enhanced proprioception, feeling from the body improves. Right, accurate reflexes, accurate prediction of targets. That is what makes brilliant performance. All right, next. Next one. Yeah, what is the time? Am I on time? No, that's all right. So you have time for discussion. Yeah, start. Okay.
Thank you, sir, for that insightful and thought-provoking keynote session. Your words have truly enriched our understanding and inspired us to think beyond conventional boundaries. Next, we move on to the question and answer session, inviting audience to raise their questions, and the floor is open for you.
No, that's all right. Any question? Please, yeah.
Yeah, it was a really different perspective to what I saw because this is one of my pet subjects that I focus on. I'm not into sports but performance, but we do deal with sports people as well. So what I want to know is how do you regulate the emotion stability of this Gen Z performers, sports, stage, anything, because it's a bit of a challenge to get them to relax, to reframe what we've been used to, your negative into positive, and the simple breathing exercise. It does not seem to be really that effective right now because the concentration is very low, especially after COVID we have seen. So how do you advise on that?
Yeah,
sir?
the thing is that I would advise if somebody is in that level, they should practice sports. Sports can automatically bring in a lot of regulation because you work within the rules and regulations of sport. So you have certain, for example, if you trip somebody down on a street, you'll be arrested. You'll be arrested. But if you trip somebody on the football court, what happens? You get a yellow card or red card. There's no case. So what I mean to say is that sport automatically regulates somebody's actions within the rules. So if somebody is, as you said, youth shows a lot of aggressive attitude these days after the COVID. That's what you said. That is why we say that people need to involve in sport more often than otherwise, especially the Gen Z. That's one. Then breathing exercise, we do use breathing during the mental conditioning sessions for the athletes. But then if you use it with a normal individual, probably its effect is not that really good. Not that really good. So the purpose, the understanding of purpose of whatever you are doing and how you perceive that purpose, how you are aware about that purpose, that is very important. So if the Gen Z is not aware about the purpose of breathing exercise, they keep doing this, but it's not going to make any change. But for the athlete knows that when we do it together, all together, we go for the breathing exercise, 4 count breathe in, 4 count holding, and 6 count breathe out, then followed by imagery or Brahmarasana, whatever it is. They know that it's an important process for getting conditioned. You know, we said automatization. That automatization is made faster and efficient through that conditioning process, psychological conditioning process. So that is one of the reasons why. So the purpose, understanding, being aware about the purpose of whatever you're doing is very important. And Gen Z probably is not, they're not that bad. They are really good in several aspects. Because we find the other day the question that yesterday, a question was raised by some journalists regarding why the youngsters are not involving in NGO organizations like Parishad and all that. We find very less youngsters involving in that. Probably they have their attitude, their way of doing things are different. They are aware about all that, like environmental issues, corruption, they are aware about all this. But the way they respond to it, the way they think that they can involve in it is totally different, actually. So that is kind of a transition that is happening. So we know what happened in Nepal during the uprising in Nepal. The Gen Z was totally involved in that uprising. So it's not that they keep away from those things, but they involve in a different way. Because the moment they understand that purpose and they think that it is of some use, they'll get grip of it. So the moment they start doing breathing exercise, and if they think that it's nothing, it's simply I do every day, every time I do breathing. So if the Gen Z doesn't understand the purpose of that exercise, it might not work. Yeah.
I enjoyed your lecture. Thank
That's
you,
all right.
sir.
Thanks for that.
I forgot the name of the person you explained about this theory when you started your lecture. So just wanted to know whether this whole thing has any connection towards the Freudian stages of psychoanalytical theory of brains development and all.
Actually,
And the second one is especially on the sport like soccer, hockey, when they play inside the box, when in very crucial situations, they have to take decisions very instantly, very quickly. So that has an internal focus as well as an external effect. So what's your take on it? How will you?
those internal and external thing works seamlessly actually. Seamlessly, because they are so conditioned to it, they immediately, the moment they perceive that stimulus in the environment, the response comes so fast. It happens seamlessly. There is no division. You wouldn't be able to find any division between that. That's why we found that it's an important question, because I forgot one important piece of information about basal ganglia and cerebellum. I'm sorry about it. Certain experiments have identified that basal ganglia as well as cerebellum has got limited cognitive capacity. You know what I mean? Within that region, they can thinking capacity. It's not like high level thinking, but immediately, some kind of a reflex thinking is possible. How they identified this was when they tested the brains of people with lesion studies. We call it lesion studies. Tested the brains of people with injuries in cortex region. They still found they have cognitive abilities. The cortex is gone. So they think that the cognitive process shouldn't be working. But they found that they have cognitive abilities. Limited cognitive process they are able to do. So they have found that cerebellum as well as basal ganglia has got limited cognitive powers. Limited cognitive powers. That's very important. That is one region. That's one of the things that I kept telling. I used to say that if we need brilliant sportsmen, we need people with better basal ganglia and cerebellum with enlarged cognitive powers. Enlarged cognitive powers. So when we teach them, when we make them do this imagery and all that, I personally think that they probably are developing more cognitive powers at their basal ganglia and cerebellum regions, so that they can make quick decisions, quick thinking, possible. Yeah. Anything else? Wilfred sir, any question for me? Lobby, Yeah. Chunking means, for example, joining together different parts of the motor action, actually. Okay? There are different parts of motor action, so those parts can be chunked together to make it easy for people to, switch on, switch off. അത് പോസിബിൾ ആവാൻ സാധ്യതയില്ല. ഐ നോ ദാറ്റ് ഹി ഈസ് റെഫറിങ് ടു സോനു. സോനു ഇസ് നെവർ സ്വിച്ചസ് ഓഫ്. കൊച്ചു കുട്ടികൾക്ക് അത് ബുദ്ധിമുട്ടായിരിക്കാം. പക്ഷേ ഇതിൽ ഒരു കാര്യമുള്ളത്, നമ്മുടെ പ്രീ ഫ്രണ്ടൽ കോർട്ടക്സിനെ കുറിച്ച് പറഞ്ഞല്ലോ. ഐ വാസ് ടോക്കിംഗ് അബൌട്ട് ദ പ്രീ ഫ്രണ്ടൽ കോർട്ടക്സ്. ഐ എം സോറി, ഐ ഷിഫ്റ്റഡ് ഇൻ ടു മലയാളം ഇൻ ബിറ്റ്വീൻ. This prefrontal cortex is one area of the brain that takes time to get matured. Even in mid-20s, it's still getting matured. Prefrontal cortex, the decision making and the working memory and all that. So that is one reason that decides maturity, as well as late blooming. Late blooming, the kind of development of prefrontal cortex. So it's not easy actually to switch on, switch off specifically. It needs some practice actually. It needs some practice. Even high level sportsmen within the Indian team, I know that they find it really very difficult to switch on at the right time and switch off at the right time. So it's an important skill. There is no doubt about it. Especially in target sports, it's a very, very, very important skill. You should know when to switch off and when to switch on. Any idea? Any question?
Define or say explain. Some some children are mentally slightly down, and but they perform very highly in some of the activities. What is the
It is only one thing, interest. They are interested in it, they do better. But sometimes you mean to say that they keep very calm, quiet and all that?
not only calm quiet, their mental faculty also is weak down, but they excel in some activity.
Because it's interest, it is interest one thing. The other explanation at the functional level could be their cognitive abilities are a bit down, but their motor abilities are, yeah. That could be genetic also, possibly. Yeah, their cognitive areas are not that active, but yeah, omega 3. Yeah, he knows. There is answer. Eat a lot of sardine. Lot of sardine. Salmon is also good. Salmon, you mean salmon. Salmon is also good. Brain food. Yeah, because why they say that, because we have the brain into two halves here. So yeah, so if you are using left hand, that means the right half of the brain is getting activated. So the right half of the brain is responsible for those things that you were talking about. See, that's only an outside chance. Like, it can happen, but nobody does that actually, really. Nobody does that consciously. Consciously, nobody does that, and I haven't found any research like that. You can do your doctorate on that. All right. Okay, let us wind up. Thanks for patient hearing, especially to the youngsters. Thank you.
Thank you, sir. We would like to express our heartfelt gratitude to Dr. Soni Jonty for your insightful keynote address. Your expertise and passion have inspired us all. As a token of appreciation, we would like to present you with this memento and certificate. For this, I would like to welcome Dr. Leons Wilfred Voss, who served as a professor and dean in the Lakshmibai National Institute of Physical Education, to present the certificate and memento. Also requesting all other dignitaries to join. Hereby, we come to the end of the keynote session. Next, we will have the paper presentation session.
Now we move on to the track 7 offline paper presentation session. The track 7 paper presentation will be chaired by Dr. Madhavan N and co-chaired by Mr. Rajesh Prasad KP.